They started out a generation ago as simple black and white ping pong games on a TV screen. Today's video games are vivid, sophisticated, and fast-moving, driven by state-of-the-art computer software featuring the latest in high-tech graphics. It all started in 1952 with a Cambridge University PhD thesis on human-computer interaction. The student invented a primitive tic-tac-toe game on a vacuum tube computer, the very first computer game with graphics. A team at MIT designed the first recognized computer game in 1962. Then, in 1972, a Stanford student invented the arcade game Pong, which later became a home video game to play on your TV set. It all begins with the people who form what's called the core team. They brainstorm in meeting after meeting to hammer out the concept, how the game will look, how it'll work. Then they plan out the production schedule, assigning who'll do what, when. They break down the game on paper and color code the components. Then they post them on a bulletin board that'll act as the production's nerve center. Now work on the artistic concept begins. Artists sketch out the characters and backgrounds on paper in a scene-by-scene storyboard. Meanwhile, graphic artists recreate those storyboard drawings three-dimensionally on the computer. This step enables the development team to use the latest in computer animation technology to bring the game elements to life by adding colors, textures, shading, and, of course, movement. After developing a preliminary version of each character, the animators superimpose a skeleton. By manipulating the skeleton, they make the character move. They experiment with different movements until they decide on which ones they'll use for the game. The animators have to design every movement each character can potentially make in the game. That's 700 movements for this main character alone. Once that's done, they flesh out the character's features and costumes to completion. The evolution of the characters from the first pencil drawing to the final version is quite remarkable. Other animators work on the backgrounds, the game's playing field. Once they have a rough version laid out, they refine it by adding details, colors, and textures. To give it depth and dimension, they use virtual lighting to create shading and shadows. To advance the storyline, this particular video game is interspersed with 1-minute animated movies. These segments, called cinematics, are animated in high resolution to produce a top-quality image. The interactive game, on the other hand, is in low resolution because computers can't process high-res images quickly enough for fast-moving play. So the animators have to create every character twice in both high and low resolution. Meanwhile, for the cinematics, they animate the storyboard using rough draft characters. This is simply to calculate the timing and to map out a clear path across the backgrounds so that the characters don't collide with the scenery. To make the cinematics action look realistic, they use a technique called motion capture. The animators videotape themselves performing the action, then use animation software to reproduce it on the computer. Computer programmers create the video game's menu settings, among other features. Computer engineers design the artificial intelligence, the brain that runs the game. It's made up of thousands of computer codes. For the cinematics, actors record the characters' lines in a sound studio. An audio technician mixes the voices with music and sound effects and synchronizes everything with the action. Now they take the video game out for a test drive. Do the characters move the way they're supposed to? Do they go where they're supposed to? Or do they run into trees and walk through walls? This is the development team's last chance to rid the game of any bugs. After that, the company can finally market this video game and hope it becomes a hit.